Hey, Pretentious engineer here. I know you didn't ask, but I work on robotic surgical devices for Johnson & Johnson. So these tools are like put inside of people's bodies in order to cut out different parts of cancer and then put them back together. Really fun stuff, but I've worked on mechanism development as well as software. And I thought it'd be fun to go through this video, and there's at least like 40 mechanisms in here, and just share which ones either I've developed or I've seen other people develop and utilize inside surgical tools for cancer procedures, because I thought that'd be fun. So let's get started. I've seen sun and planetary gears, which is a lot of fun. What is this one? I've seen that in a tool. I can't disclose which tools because some of them are in development and some exist today. Have I seen that one? I think not on that one. Some of the designs we do are really small, so it's challenging to fit. I've definitely seen the gear, the gear. I've seen belts. I've seen pulleys. Constant gear. I have seen switching mechanisms for different functions off of one input with another one. That's really cool. Oscillating device, directional changer. I have not seen that. I've seen torque limiters. It's really cool how much you can actually do with Legos. I think these are Legos. Yep, I've seen whinging. This is so exciting. I designed a rack and pinion. I actually did a double rack and pinion once where it would change directions from two inputs. I've seen offset gears. Let's see, what else? Unidirectional drive. I don't know if I've seen that one. But there's some tools that had like at least 23 gears inside. It's crazy. I've seen cams. Cams are amazing. Very helpful. They're a little bit difficult in small form factors, but still possible. I've seen intermittent mechanisms. What else do we got? I've done worm gears. Really good at transmitting torque. What? Oh, he put them all together. He or she or whoever. Oh, that's lovely. Oh, this makes me so happy. But yeah, so that's the fun part about design. There's so many different ways to take movement from one direction and translate to another. It also depends on what kind of application you're doing, the form factor, how small it is or big it is, how much torque you're trying to transmit or how much force, because different mechanisms are optimized for different sizes and loads and speeds. So it's really cool seeing, different engineers navigate different user requirements in order to develop the right surgical tools. I mean, this is like a large combination of mechanisms, but a robotic surgical tool is like this, just compressed. So anyway, keep designing, friends. You can sip on that.